For this series circuit, let's calculate now the total resistance that's going through this circuit. So we're going to look for total resistance. And so that will be RT is what the way we'll refer to it. So we know that in a series circuit, if we simply take R1, RT is equal to R1 plus R2 plus R3. Pardon?
Is R1 220? Yes.
Yep. Okay. If we get the sum of those and get the total, then we will have the total current or the total resistance. So since that's true, all we have to do here is to just simply add the resistance through the or the ohms there through those resistors. So 220 ohms plus 470 ohms plus. Now this is 1.2, and I'm going to keep apples to apples here with everything else. So I want to make this 1200 ohms. Okay. You know why I did that, right? That's just to keep apples to apples. All right, so if we add those up, we will come up with 1890 ohms. Now, generally speaking, we will round that up to about 1900, okay? Or if you state it as 1.89 kiloohms, that will be what we actually would be looking for on the test. So you want to get it to its most friendly denominator there. Okay? Any questions on how you get on for a series circuit only, how you get the resistance? Okay? So that's the resistance. So now let's get the current. So I'm going to come down here. Maybe I'll have enough room here. And we'll see if we can get the current through the components. When I say components, what am I talking about? It's these resistors. Anything that's in line with this circuit, like the resistors, there may be a switch or something like that, but that's what I'm talking about when I say components. Okay, so to get the current through each resistor on a series, or through each component on a series circuit, the formula is current total is equal to, it's the volts over the resistance. Volts over the resistance. And since we're looking for a total here, we're looking for the total values. Okay, the total values to fill in there and to sub. So what is our volts in this circuit? Okay, so we'll put 12 volts there. And so we're also looking for the resistance here, which is 1.89. We just calculated. Okay, and then when we do that math, we'll come up with milliamps, 6.3 milliamps. Okay, so that formula was volts, I equals volts over the resistance total. Okay, so that was the formula that we'll be working with there. And that's for a series circuit. Okay? Now, we've got resistance, we've worked it, and we've worked current. What is the other component that we need? We need the volts. So I'll go to another page here. We'll work the volts. So for that same circuit, this is the calculation to work the volts. We have to get V1 equals I1 times R1. Now we're talking about Ohm's law here, right? Let me just state that since I haven't said that yet. Ohm's law. Okay, because you may see that as a question somewhere. So that's what we're working with. So the formula here, now you have to kind of refer back to something here. Let's go over here and just make a note that we've already calculated the current total to be 6.3 milliamps. That was our current total. Okay, so we'll make that note. So now what we'll do in this sketch, now we're going to get V1, we're going to get V2, and we're going to get V3. So you might want to go ahead and fill in your sketches, your schematics, to show that for a series circuit you're going to be getting them in that order. So with R1 you'll have V1, with R2 you'll have V2, and with R3 you'll have V3. Okay. So let's look for V1. V1 is equal to the current across the first component, which is here. Again, we're starting in this direction. Okay, so we're going through the component, the first component. So we're going to be looking at the power or the current going through that component, and we just calculated that. What is it? 6.3 milliamps. We're going to multiply that by R1. What is R1 in our diagram? 220 ohms. No, that's ohms. Okay, when you do that math, your unit is going to be volts. You're going to come up with 1.39 volts. So now let's get V2. So we're just going around the horn, so to speak. If you're a baseball player, you know what that means. You're just kind of going around in sequence. So let's get V2. And here's the thing with the series circuit: the current going through each component will be the same. The current going through each component will be the same. So what number would I plug in here for our current? 6.3 milliamps. And what is R2? What is R2? 470 ohms. And that gives us 2.96 volts when you do the math. So we have one more component, one more resistor, and that will be to get the voltage across V3. And again, we'll plug in our known, 6.3 milliamps times what is our resistance? 1.2K. I'll just take it up to 1200 ohms. And with that math, I get 7.6 volts. 7.60 if you want to make it match the other decimal points. Okay? Now, there's a law called to verify our math here, and it's basically Kirchhoff's law of voltage. And Kirchhoff's law of voltage, and I think I'm saying his name right, Kirchhoff. Says this, that the total voltage will be equal to V1 plus V2 plus V3. So if we know what our total voltage is, back from our schematic, and it was 12 volts, right? Our power source was 12 volts. That means if we add that voltage plus that voltage plus that voltage, we should get roughly 12 volts. Now it may be 11.95, 11.96, something like that, but it should round up real close to 12 volts. Okay? So in a problem I may say verify using Kirchhoff's law of voltage your math, or I'll say it some way like that. Okay? So that's a series circuit. Series circuits are pretty straightforward. Any questions on that? Okay. So let's look at a parallel circuit. Let's start out by getting the total resistance. So let's find for the total resistance that's in that circuit. And the formula to find total resistance is this. RT is equal to 1 over 1 divided by R1 plus 1 over R2 plus 1 over R3. Remember that? So we're getting reciprocals here. See if I've got enough room. I didn't write too big. Alright, so basically all we're doing here, once we get the equation set up, we're simply just doing some plug and chug activity. So we'll say RT, which is the resistance total, is equal to 1 over, what is R1? Over 470 plus 1, that's 2.2K, so we'll call it 2200 here, plus 1 over, what's the next one? 3,300. So when you do the math, okay, if you round this up to 350, which is typical, because resistors don't come in 346.59 ohms, you go up to the next one. So if you did that, or if you left it without rounding it, that answer would be fine. I would take either one. So that's the finding for the resistance. Any questions on that? That's pretty straightforward. All right, so this is finding for resistance. Now we need to, let's just go ahead and find for, I'll tell you what, instead of finding for something, since this is let's talk about voltage. And since this is a parallel circuit, the voltage total is going to be the same across all components. In other words, the voltage total is this. V1 is equal to V2 is equal to V3. And what was our volts that I set up in the schematic? Look at your engineering notebook. When you drew the schematic, how many volts did you apply to it? 15. So this is 15 volts. This is 15 volts. This is 15 volts. And that's 15 volts. Okay? Only for a parallel circuit. Parallel circuit. So you need to make a note and put a little asterisk by that. Okay? Now, so we got voltage taken care of, so let's look at current. And we're talking through each component. Of that parallel circuit. So this will be the formula that we'll be working with. I is equal to V over R, and that's what Ohm's law states for us. Now, notice I put I1, R1, V1. So that means we're going to have to do what? Go in steps, right? We have 3 different components, so we have to find for all 3 different components here. So we'll set this equation up for I1 is equal to, how many volts is going through I1 or R1? How many? 15, yes. Because it's a parallel circuit, it's going to be the total, and it's going to go the same through each component. So what is our R1? So we're looking for our resistance through R1. 470 ohms. When you do that math, you'll come up with 0.319 amps. Always convert to what? Always convert amps to what? Milliamps. It's the bigger number, easier to work with. Okay, so we now have I2 is equal to how many volts? 15, because we're dealing the same with for a parallel circuit. How much is the resistance? And that will come up to, when you do the math, .8 milliamps. I3, the power across I3 is equal to 15 volts. What's our resistance? And when we do that math, you get amps, 0.045 amps, or 4.5 milliamps. Now, the cool thing here is we know what it's going to be real easy to find our IT, or our current. And we can find that by simply doing this. We know our current's going to be the same, right? Or our voltage is going to be the same. We have already calculated our R total, right? What was our R total?
350.
I'll use what I come up with here, but yeah, 350 if you round that up. So IT is equal to 15 volts over that 346 ohms, divided, which is 0.043 amps. or 43, that's really 43.2 milliamps. Now, Kirchhoff's current law, to get to verify this, says this. And this is for a parallel circuit. Says this, that the total current is equal to I1 plus I2 plus I3. So we came up with 43 milliamps. So if we go back and look at our I1 that we calculated, what did we get? What was our I1? 31.9 milliamps. Plus, what was our I2? 6.8. What was our I3?
4.5.
Add those up, I come up with 43.2 milliamps. So we have just used Kirchhoff's law of current, referring to a parallel circuit, and we've just verified our math.